Hey everyone, because I am not here today, I thought it might be a good idea to film a video to kind of help you with the worksheet. So this is going to be one of 2 or 3 videos, just depending on how long they get. But again, we went over this last time. This is just review. You should be able to do the worksheet at this point, but I understand that these concepts can be a little bit challenging. So even if you just want to use this for your own reference, and I'm going to start. So the first thing we want to review when we talk about stoichiometry and using stoichiometry as a form of conversions, we need to remember that 1 mole is equal to 6.02 times 10 to the 23rd atoms. Okay. Now, 1 mole is also equal to some type of molar mass. And this is different for each element or for each compound. And you need to utilize the periodic table for this. If you don't have a periodic table, you're not going to be able to do this worksheet. You're not going to be able to do anything. So let's go right into an example of how we apply this into word problems or questions that you might see. So the first example I want to give you is how many moles of indium are in 114.82 grams of indium. Okay. We can also ask the question, how many atoms of indium are in that sample? So indium is on the periodic table. It's IN. And the first thing we should look up is indium's molar mass. So if we go to the periodic table and we look at indium, the molar mass or the atomic mass is going to be 114.82, which is the number at the bottom. And the units are grams per mole. Okay. And the way that we're going to solve this problem, and again, it should be review from last time, is use this idea of dimensional analysis, setting up our math so that we can multiply and divide pretty easily. And we did this at the beginning of the year. We did this a little bit last class. But I'm going to remind you to always, number 1, start with what is given to you. You can't go wrong by starting what's given to you. And then number 2, use conversion factors to cancel what you don't need. So the question is asking how many moles are in 114.82 grams. This is what's given to us. So we want to start by writing 114.82 grams. It might also be beneficial for you to put some kind of end result. So we want moles from that, okay? So what we do is, again, start with what we're given. And I like to write the unit and the actual sample as well. Now we want to set up, I call them boxes, our conversion factor. And we know that 1 mole of indium equals 114.82 grams of indium. Okay? This is our conversion factor, which means one is going to go on the top and one is going to go on the bottom. And we can choose, either can go on the top or the bottom. But remember that we want to cancel grams and end up in moles. And the way that we cancel grams is if one is on the top, we put it on the bottom. Okay? So we just really fill this out. All the information is given to us. It's either given to us in the problem, or it's on the periodic table, or it's Avogadro's number. Okay? So if we do this, we can cancel grams. And we shouldn't need a calculator for this because all we're doing is dividing 114.82 divided by 114.82, which gives us 1 mole. And that's exactly right. 1 mole of indium is equal to 114.82 grams. Now, we did the first part, so we have 1 mole. Now it's asking how many atoms are in 1 mole of indium. Now here, we have to use Avogadro's number so that we can end in atoms. And again, 1 mole of anything is equal to 6.02 times 10 to the 23rd atoms. So we have 6.02 times 10 to the 23rd up here, 1 mole, which means we have 6.02 times 10 to the 23rd atoms of indium in that specific sample. And again, this was a very, very basic example because it ended up being 1 mole and exactly 6.02 times 10 to the 23rd. But we can use this math for anything that we want. I do want to go over just some nomenclature. This number, 6.02 times 10 to the 23rd, is in fact Avogadro's number, is in fact pertaining to atoms. But if we're unsure of the substance, we can also say representative particles. If we don't know what the substance is, we don't know if it's an atom, a molecule, or a compound, we can use the word representative particle as a kind of umbrella term. With that being said, we could also use a series of other names as well. If we have something like sodium, the base of sodium is an atom. So we would use an atom for that number. But let's say we have something like NaCl. This is no longer an atom. This is now a molecule. So in 1 mole of NaCl, we'd have 6.02 times 10 to the 23 molecules. If we have something like NaOC3, this is now 3 elements, so it's a compound. So we'd have 6.02 times 10 to the 23rd compounds. If we had Na+, this is no longer an atom now, this is an ion. So this number changes, this number doesn't change but the name of it changes depending on what we have. You could also see the word formula units. Again, representative particles. And again, the number doesn't change, just the term changes depending on the actual molecule that we're talking about, or depending on the substance that we're talking about. The last thing I want to go over is kind of an infographic that I created that's going to help us convert between mass, moles, and atoms or particles. And I did this last time, but I'm going to draw it out again. And let's say that we are living in some kind of state that has 3 places to visit. The first one's Masstown, the second one's Moleville, and the last one I'm gonna call Particle City. Not Party City, Particle City, which is in fact atoms. This little infographic's gonna tell you how to convert and how to do this kind of intuitively. It should become very natural at the end. But let's say that we want to go from moles to mass. So we're going from Moleville to Masstown. The molar mass would have to go on top, which is grams, and we divide that by the number of moles that we have. And if we wanted to go from mass to moles, we'd do exactly the opposite. We'd put the number of moles on top and the molar mass on the bottom. Okay? And it's the same kind of principle if we wanted to go from atoms to moles. We would put 1 mole on top and 6.02 times 10 to the 23rd on the bottom. And lastly, if we wanted to go from moles to atoms, we know the drill. We just flip that around and put 6.02 times 10 to the 23rd on top over 1 mole. Okay. And finally, if we wanted to go from mass to particles, we can't just do it straight away. Okay? We have to go from mass to moles to particles. Same thing if we wanted to go from particles to mass, we can't do this. This is incorrect. We have to go from particles to moles to mass. Stay tuned for the next video.